Good afternoon, everyone. I am Harshad Lonare from Pipri Chinchod College of Engineering and Research, Ravet, Pune, Department of Mechanical Engineering. Our subject is Engineering Thermodynamics. We have prepared a PPT on Fundamental of Thermodynamics, and our group members are Harshad Lonare, me, and Chetan Hole. And our PPT and our group is guided by Professor Rahul Bhavne sir. And content is in PPTs are introduction, system, surrounding and boundaries, types of system, properties of system, types of boundary, homogeneous and heterogeneous system, thermodynamic equilibrium, types of process and application. Further, Chetan will carry on.
Yes, thank you. Next part is Introduction to Thermodynamics. The thermodynamics is a word derived from thermo and dynamics. The Latin word thermo means heat and dynamics means power and force. Means so overall meaning of thermodynamics is a heat, power or force interaction between system and surrounding. Means overall thermodynamics means is a science which deal with energy transfer and its effect on the condition of system. The next topic is system, surrounding and boundary. System means it is a thermodynamic system is defined as the fixed mass in region or space under consideration of or to analyze the problem. Boundary is fixed limit to the system. The system and surrounding is separated by boundary. It will not occupy any volume or mass. Then surrounding is anything outside the system is called surrounding. Then next is types of system. There are three main types of system: closed system, open system and isolated system. First, closed system. A system consists of fixed amount of mass and no mass may cross the system boundary, but energy is form of heat and work may cross the system boundary. Means there is a no mass transfer, only energy transfer across the boundary. For example, hot water bag. We know that hot water bag which is used to get relief from muscular pain, but heat can transfer but water is not transfer, it remain in that bag. So next is second is open system, the system which mass along with energy transfer across the boundary, so called as open system. For example, pump, compressor and turbine. We know that in the compressor we provide as a work, then compressor air can enter and leave the system. Then third is isolated system. If there is a no mass and energy transfer between the system and surrounding, is called isolated system. For example, thermos flux, but there is a no isolated system in the universe. Then next is properties of system. There are two types of properties of system. There first is intensive property and second is extensive property. Intensive property means the property which are not depend on mass, so called as intensive property. For example, pressure, temperature, viscosity. Then next is extensive property, the property which depend on mass and size of system, so called as extensive property. For example, length, volume and all form of energies and entropy. Then next is types of boundary. There are two main types of boundary. First is fixed boundary and second is moving boundary. Fixed boundary means has a definite shape and includes a fixed region of universe. For example, system of turbine has a fixed boundaries, and second is moving boundary. It has changed its shape and its region of universe to enclose by it. For example, balloon. The next PPT is present by Harshad.
Homogeneous and heterogeneous system. First one, homogeneous system. A system which consists of single phase is termed as homogeneous system. It is defined as a single unit in which it is termed as a homogeneous system. Example, ice, water, mixture of air and water vapor. Second one, heterogeneous system. A system which consists of two or more phases is called as a heterogeneous system. In other words, we can tell that two or more unit are come together, then it is known as a heterogeneous system. Example, water plus steam, ice plus water, water plus oil, etc. etc. Thermodynamic equilibrium. A system will be in thermodynamic equilibrium when it satisfies the condition of mechanical, thermal, and chemical equilibrium. First one, mechanical equilibrium. A system is said to be in mechanical equilibrium when there are no unbalanced force in the interior of the system with its surrounding. Second one is thermodynamic equilibrium, in which uh, there is uniformity of temperature in the system with its surrounding, is known as thermal equilibrium. Third one, chemical equilibrium. The chemical equilibrium represents the absence of any chemical reaction in a system, or else we can say that there is absence of chemical reaction in a system is known as a chemical equilibrium. Types of property, types of process: isobaric process, isothermal process, and isochoric process. First one, isobaric process. In first diagram, we can see that pressure is constant. Then we can say that constant pressure process. Second one, isothermal process, which is last one diagram. Isothermal process. There is a change in temperature uh, for both the diagram. Then we can say that constant temperature process. Third one, isochoric process. Second diagram, we can see that constant volume in the process. So that a constant volume process. Next, last is applications of thermodynamics. We can see thermodynamics in steam power plant, IC engine, refrigerator and air conditioning, gas turbine and compressor, and etc. Thank you.
Welcome. Hello.